It is my pleasure to welcome you to this, the BCS Lovelace Lecture of 2014, to be given by Samson Abramsky, the 2013 Lovelace Lecture medalist. I feel particularly qualified to welcome you because not only am I the chair of the BCS Academy, I'm also Dean of the Faculty of Engineering here, so welcome to this BCS event, but also welcome to Imperial College, those of you who don't spend their life here. The Lovelace Medal was established by the BCS in 1998. The medal is presented to individuals who have made a contribution which is of major significance in the advancement of information systems, or which adds significantly to the understanding of information systems. It's given in memory and honor of the great Ada Lovelace, mathematician and scientist who worked with Charles Babbage, the inspirational computer pioneer. Now, over the years, the medal has been awarded to a number of distinguished computing scientists, including Karen Spark-Jones, Sir Tim Berners-Lee, and Linus Torvalds. And joining this list of distinguished scientists is the winner of the 2013 Lovelace Medal, Professor Samson Abramsky. Samson Abramsky is the Christopher Strachey Professor of Computing and Fellow of Wolfson College, Oxford University. Previously, he held chairs at Imperial College of Science and Technology, here, he made the mistake of leaving, and at the University of Edinburgh. He holds MA degrees from Cambridge and Oxford and a PhD from the University of London. He's a Fellow of the Royal Society, a Fellow of the Royal Society of Edinburgh, a member of the Academia Europaea. His paper on domain theory in logical form won the LIX Test of Time Award, which is a spectacular award. It's for a 20-year retrospective looking at the impact of research. And this was awarded for a paper he wrote in 1987. He was awarded an EPSRC Senior Research Fellowship on Foundational Structure and Methods for Quantum Informatics in 2007, and he was awarded the BCS Lovelace Medal, of course, last year. He has played a leading role in the development of game semantics and its application to the semantics of programming languages. Other notable contributions include his work on domain theory and logical form, the lazy-lambda calculus, strictness analysis, concurrency theory, interaction categories, and geometry of interaction. More recently, and what he'll be talking about tonight, he's been working on high-level methods for quantum computation information. Truly a talented computer scientist. So I'm delighted that the BCS is able to recognize the outstanding and sustained contribution of Professor Abramsky. Samson, can I ask you to join me on the stage to receive the BCS Lovelace Medal? And can I ask Philippa Gardner, who chaired the awards committee, to come on stage to present the award? So I'm afraid we're not quite finished the introduction yet, so I'm going to ask Samson to restrain himself for a few minutes while I ask Bill Roscoe, Professor Bill Roscoe from Oxford, to say a few words more about and to celebrate this award to Samson. Bill.
I can't quite remember when I first met Samson, but I'm sure it was well over 30 years ago. He was always sort of just there in my career. We're more or less contemporaries. But whereas my career has followed the conventional pattern of research into administration, I've been head of department of Oxford University Computer Science Department now since 2003, but fortunately this is the end this summer. Samson has pursued what can only be described as the perfect academic career, because he has basically followed a superb intuition for elegance in research and has pursued his instincts, which have obviously been completely immaculate, through all the different areas that Jeff pointed out. I was on the electoral board that something we have at Oxford, which appointed Sampson to his Oxford chair at the turn of the century. And we thought then, of course, that we were getting a classical theoretical computer scientist, which of course we were. Little were we to imagine that we were going to have a quantum theorist, somebody interested in quantum information, quantum cryptography, teleportation, and things like this, because of course he wasn't at the time. But I'm presently working with Sampson in helping to enable him participate in the university's bid in quantum technology. And who would have believed that 14 or 15 years ago when he was preparing to come to Oxford? I think that his decision to follow his nose into quantum, as I say, represents wonderful intuition, but also tremendous bravery. Because who amongst us would feel comfortable in basically invading the territory of such a powerful and established group of scientists like this? And the splash that he and his group at Oxford and co-workers around the world are making is, as I say, testament to the power of the ideas that he and his co-workers have brought to this. I have two big words in capitals written in my notes here, which are category theory. But perhaps this lecture could be entitled "The Unreasonable Effectiveness of Category Theory." I'm not sure it could be. I'm not a category theorist myself, but I'm impressed at what's been achieved by it. I just want to summarise a little bit of the impact that Sampson has made on Oxford. He, of course, as I say, very much sets the tone. He took over Tony Hoare's chair. I think Tony Hoare left us, retired in 1999, and Sampson took over the chair in 2000, didn't you? With a year's break. But we couldn't imagine a better succession to Tony Hoare than Sampson, and in many ways, the styles of their work while obviously very different, are also have much in common. Tony, it was said, and I'm living proof of this, populated the department with his own protégés. Sampson has done a little bit of effort on that front. We currently have what I would describe as two of Sampson's protégés as professors in our department. We have Luke Ong and Bob Cooker. What very different people. But both, of course, make wonderful contributions to the department and help to set the very diverse tone that we have today. But anyway, it now falls to me to introduce Sampson, to give the lecture, which is titled Contextual Semantics from Quantum Mechanics to Logic, Databases, Constraints, Complexity, and Natural Language Semantics. So, Sampson.